Hello everyone, welcome back to Pre-Algebra with Miss Betsy. Today we are going to be talking about mixture problems. With the very specific example that we're going to use first today. There's a farmer, he's got some corn and he has some barley and he wants to mix some of that together so that he ends up with 150 pounds of what they call silage, additive to feed to his cattle, and he wants that to have a very specific value. Cost value per bushel based on the amount of corn and the amount of barley that it has inside of it. So what we're going to see is how you can calculate that. First though, I want to read you a riddle and see if you can solve this. I have feathers to help me fly. I have a body and a head, but I'm not alive. It's your strength that determines how far I go. You can hold me in your hand, but I'm never thrown. What am I? I'm an arrow. It has feathers, it has a body, it has a head, it's not alive. It's how strong your pull is that determines how far that arrow flies. You hold that arrow in your hand, but you're not ever going to throw it. So that's your riddle for today. Okay, we are now in section 410, which is mixture problems. If you're using the same text that I am, this is page 169 in Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the first edition. You can use any basic pre-algebra, Algebra 1, even some Algebra 2 books to work these problems because the concepts are the same. The approach is the same, just taught in a different book. Here's our problem. A feed store owner wants to mix corn and barley to make 150 bushels of silage additive for cattle feed. If corn costs $2.40 a bushel and barley costs $2.20 a bushel, how many bushels of each grain should he mix to yield an additive worth $2.34 a bushel? This sounds scary. It sounds like there's no way in the world that you can possibly come up with this. Once again, look at your problem, or step back from your problem, take a deep breath, say, okay, Lord, would you please help me to figure out how to solve this problem? And I'm serious about the praying. You know, I pray all the time. You know, God is the one who created us. All of math comes from His design. Ask Him to give you the ability to understand your schoolwork. Now, does that mean that He cracks your head open and pours the answers in? No, typically not. You have to work, but you ask Him to help you. His word tells us that if any man lacks wisdom, let him ask of God who gives to all men generously. Ask Him to help you understand your schoolwork, and He will help you. So back to this. What are we going to do? It says, read the problem carefully to find the unknown quantity. We want to know how many bushels of corn and how many bushels of barley are we going to combine together so that we have a total number of bushels of mixture of 150. So we have a mix of corn here. We have a silage mix. Total number of bushels is 150. Now if I tell you that I have coins in my hand, and I have 10 coins, and I know some of them are nickels, and some of them are dimes, and I wanted to be able to begin to put together an algebraic expression to help me determine the number of nickels and dimes that I have, I could just pick at random. Let's say I have X number of nickels. How many dimes do I have? Well, I'm going to have the total number of coins minus the number of nickels. Is this true? Sure. Well, let's say that I have 3 nickels. How many dimes do I have? I have 7 dimes. The number of dimes is the total number of coins minus the number of nickels. 10 minus 3 is 7 dimes. That's the principle that you're going to be using in mixture problems. Someplace you're going to have a total quantity, and then you're going to use your variable in that total quantity to come up with an expression involving an unknown, so you can figure out the missing information, the required information, which in this case is how much corn, how much barley do I need to mix together so that I have 150 pounds of silage additive altogether. So it makes no difference, lost my eraser, it makes no difference here if we'd said that X was the number of nickels or X was the number of dimes, because when you subtract one quantity from the total number, when you're only dealing with nickels and dimes, your difference is the number of the second quantity, which is a very convoluted way of saying, if we know that we have 150 pounds of mixture, we can just randomly go ahead and say, let X be the number of bushels of corn. If I'd had barley here first, I could just as easily have said, let X be the number of bushels of barley. It doesn't make any difference. If I have 150 bushels, and I have X bushels of barley, of corn, then my barley has to be the amount of bushels that I have remaining after I have subtracted out from that the number of bushels of corn. Total mixture is 150 minus the bushels of corn, which would be X. Tells me that the variable expression for the barley is 150 minus X. Now, how much is the corn? Our problem tells us that the price for the corn is $2.40 a bushel, 2.40. The price for the barley is $2.20. We want our mixture to have a value of $2.34 a pound. Notice how I set this up: 2.40, 2.20, 2.34, representing dollars and cents. The price for one bushel is $2.40. The price for the total number of bushels, you multiply together, 2.40 times X, 2.40X. 2.20 times 150 minus X, and 150 times 2.34. Oh, look at that. There's not even a variable expression in there. I want you to go ahead and do this multiplication. That will come up to be $351 is the total value of that mixture. Now, what we have, all of these pieces of information, what can we put together that is meaningful, that has a variable expression, contains a variable, so that we can solve a problem here? Well, let's go ahead and look at this and think, the number of bushels together, that doesn't help us with any unknown. We can't figure out what X is. Price, we can't figure out what X is for one bushel. However, if we've got the cost of the corn plus the cost of the barley, that's going to give us the total cost of the mixture. That's like doing a recipe. You have to know the cost of your ingredients to know how much money you have invested in your total result. So the cost of the corn, total cost of the corn, 2.40X plus 2.20 times 150 minus X is equal to the total value of the mixture, of the combined mixture combination itself, of $351. So now we have these decimals introduced here into our problem, and we want to go ahead and clear the equation of decimals. We did this by multiplying by a power of 10. We've talked about this earlier in the year. Now I'm looking at this. I have 2.40, 2.20. I had to have two decimal places for the $2.34. I really don't need the two decimal places for the $2.40, $2.20. So that will make our arithmetic easier, but we still have to just say 2.4, 2.2. We still have to move that decimal point so that we're adding, multiplying whole numbers. What are we going to do? We're going to multiply both sides of this equation by 10. And I'm going to go ahead and bracket this off so that you can see that we're going to multiply each side of this equation by 10. I'm not going to get all hung up here in the distribution, but I'm going to show you how this works. We have 10 times 2.4, move the decimal point 1 unit to the right. You have 24x. Now we have to say 10 times this expression in here. 10 times 2.2 times the quantity 150 minus x. We have three factors together. 10 times 2.2 times this expression. Multiplication in order from left to right. 10 times 2.2 gives me 22 times the quantity 150 minus x is equal to 3510 because we multiplied 351 by 10. Now we have to distribute again. We have 24x plus 22 times 150, 003, hopefully I have 3,300. Let me check and make sure that I have. Yes, I have 3,300. 22 times 150 is 3,300 minus 22x is equal to 3510. I distributed 22 times 150 minus times 22 times the negative x is minus 22x. Combine like terms. 2x plus 3,300 is equal to 3510. Need to isolate the variable. You subtract 3,300 from both sides, which I'm not going to write. I'm going to have 210. Now, I don't care about 2x, so I need to divide both sides of this equation by 2. X is equal to 105. 105 what? At this point in the problem, I've forgotten what I've even trying to do. Look back up here and say, oh, I remember. I want to know how much corn, how much barley am I going to mix together so that I have a total number of bushels of this mixture, which is 150. My x is the number of bushels of corn. So we have 105 bushels of corn. 150 minus 105 is the bushels of barley, which would be 45 bushels . 45 bushels of barley. Now, how in the world would you check that problem? Well, there are a couple of different ways that you can check it. And that has to do with, okay, 105 bushels of corn times $2.40 gives me a certain amount. 45 bushels times $2.20 gives me a certain cost for the barley. You can add together the cost of the barley and combine that with the cost of the corn, and you'll be able to verify that the cost of that mixture is $351. This right here is the solution to your mixture problem. These take time to think through, time to set up, careful attention to detail when you're doing your equation, but you can totally do these. Just work on them, take your time, do your best. This was the end of part 1 of mixture problems. I'll come back with part 2 momentarily.